It is the 26th of September, 1991. Oracle, Arizona. 8 people walk through an airlock in matching red jumpsuits. The door seals behind them, and they don't come back out for 2 years. The structure they have entered is called Biosphere Two. The engineering claim is straightforward on paper: a completely closed atmospheric loop, no external inputs, no gas exchange with the outside world. Photosynthesis produces oxygen, respiration consumes it. The cycle repeats. 8 people breathe recycled air for 24 months and prove that a self-sustaining closed ecosystem is possible. Within 6 months, oxygen is disappearing faster than the carbon dioxide data can explain. Something is consuming it that nobody modeled. The monitoring equipment shows the drawdown clearly. The cause isn't immediately obvious because the carbon dioxide readings don't tell the expected story. Oxygen is leaving the atmosphere. The corresponding carbon dioxide is not arriving. The answer isn't biological, it's structural. It was built into the walls before anyone walked through the airlock. Biosphere 2 covers 3 acres of the Sonoran Desert, 7 distinct biomes: tropical rainforest, savanna, mangrove wetland, desert, an ocean with a coral reef, an agricultural zone, and crew habitat. The enclosed atmospheric volume sits at roughly 200,000 cubic meters. Texas oil billionaire Ed Bass funded construction at $150 million. It took 7 years to build, and it remains the largest sealed structure ever constructed. The atmospheric design rested on a single core assumption: that photosynthesis across the rainforest, savanna, and agricultural biomes would balance respiration from 8 humans and the soil ecosystem over annual cycles. Light in, carbon fixed, oxygen released. Organic matter consumed, carbon returned. The loop closes. 2 design decisions complicated that assumption from the start. The first concerns the crew. The 8 biospherians were not selected through a rigorous scientific process. Several had lived together previously at Synergia Ranch, an intentional community in New Mexico run by John Allen, the project's founder. They were selected on trust rather than technical qualification. The second decision concerns the soil. To maximize agricultural output, the designers used soils deliberately rich in organic matter, dense with microbial life and decomposing carbon. Both decisions seemed reasonable at the time. Remember them for later. On September 26, 1991, the atmospheric monitors read a normal 20.9% oxygen. The airlock closes. The experiment begins. Within the first 3 months, oxygen begins a measurable, persistent decline. Not dramatic, not sudden, consistent. Post-mission analysis puts the average drawdown at roughly 140 parts per million per day across the first 16 months. In a sealed volume of 200,000 cubic meters, that rate is slow enough to miss on any given morning, but relentless enough to accumulate into a crisis. By month 12, oxygen sits near 17%. The crew report fatigue and persistent headaches. They attribute it to overwork and caloric shortfall. The crops are underperforming, and most of them have lost significant body weight. Operations continue. By the month 16, oxygen has fallen to approximately 14%. That figure corresponds to the atmospheric conditions at roughly 13,000 feet above sea level. At that altitude, the body struggles to extract enough oxygen from each breath to sustain normal cognitive function. The physician on the crew becomes too impaired to complete basic arithmetic. This is clinical hypoxia, and it is happening at ground level inside a sealed glass building in the Arizona desert. Now, here's the anomaly that should have been the first diagnostic signal. Carbon dioxide levels are not rising proportionally. If soil microbes were simply consuming oxygen through decomposition and exhaling carbon dioxide as a byproduct, the carbon dioxide concentration should be climbing in near lockstep with the oxygen decline. Basic chemistry demands it, but it isn't. Oxygen is disappearing from the atmosphere, and the carbon dioxide that should account for it is not accumulating in the air where instruments can detect it. Something is intercepting the carbon dioxide before it can register, pulling it out of the gas phase entirely and locking it somewhere else. The biological systems inside Biosphere 2 can account for the mass balance. The concrete can. To understand what the concrete is doing to the atmosphere, it helps to understand the chemistry at the wall surface. Biosphere 2 was built with standard concrete, nothing unusual about that. In any normal building, concrete containing calcium hydroxide sits quietly in the walls and does very little chemically. It cures, it hardens, it holds the structure up. In open air, the concentration of carbon dioxide is too low and the surface exposure too limited for any significant reaction to occur. Inside a sealed atmosphere where carbon dioxide is actively accumulating, the conditions change. Calcium hydroxide reacts with carbon dioxide to produce calcium carbonate and water. The carbon gets locked into the wall as solid mineral. This process is called carbonation, and in an open building, it is essentially irrelevant. In a sealed system with 200,000 cubic meters of air and no external replenishment, it functions as a one-way valve. Carbon enters the concrete and does not come back out, ever. Post-mission analysis confirmed this directly. Interior concrete surfaces showed roughly 10 times more calcium carbonate than exterior surfaces exposed to normal outside air. The structure had been absorbing the atmosphere, not metaphorically, measurably, chemically, permanently. The mass balance consequence follows from this. Soil microbes consume oxygen and produce carbon dioxide. That carbon dioxide contacts moist concrete and reacts to form carbonate. The oxygen used to generate that carbon dioxide is gone from the atmosphere, but the carbon it was carrying never returns to the biological cycle. It is mineralized into the walls. So the oxygen is spent, the carbon is locked away, and the net result is a slow, continuous, unrecoverable drawdown of breathable air. The atmosphere is quite literally transferring into the structure. There is one more detail that confirms the system was never what it claimed to be. Before the doors closed, an industrial carbon dioxide scrubber had been quietly installed as a contingency. Its use during the mission was not publicly disclosed. Then, after 16 months, operators pumped oxygen in from outside. The effect was immediate. The crew started laughing, running through the biomes. Observers watching from outside said that for months prior, the biospherians had been moving like people in slow motion. They were so oxygen depleted, they barely registered as the same group who had walked in. The atmospheric failure was not the only system coming apart. Without a stable oxygen supply, and with crops consistently producing fewer calories than the agricultural models had projected, the biological systems began failing in sequence. The order matters. Pollinators went first. The hummingbirds died. The honeybee colonies collapsed. Without them, crop reproduction stalled, compounding a food deficit that was already pushing the crew towards significant weight loss. Some members lost 30 pounds or more over the 2 years. Of 25 species of small vertebrates that entered the structure with the crew, 19 were gone before the mission ended. Most of the insect species that had been carefully selected and introduced did not survive either. What thrived were the species nobody had planned for. An invasive morning glory vine had entered through gaps too small to detect during construction. Inside, with no competition and no management tools adequate to stop it, it spread across the agricultural zones and strangled crops. Ants and cockroaches, also unplanned, also unaccounted for in any ecological model, multiplied without predation pressure and occupied the food stores and sleeping quarters throughout the final months of the mission. The ocean biome degraded separately. Carbon dioxide fluctuations interacted with seawater chemistry to drive acidification. The coral that had been transplanted and carefully tended bleached and died. The reef the designers had built as a functional biome was gone. And the crew fractured. 8 people in 3 acres of glass, slowly starving, operating at reduced cognitive capacity, watching the systems around them fail. Within months, they had split into 2 factions of 4 who stopped speaking to each other, except when the mission absolutely required it. One crew member later reported being spat at twice. People who had entered as colleagues passed each other in the corridors of their glass world and looked the other way. On September 26, 1993, exactly 2 years after entry, the 8 biospherians walked back out. The atmospheric collapse was not a single-point failure. It was the intersection of 3 unmodeled variables: microbial respiration rates in organic-rich soil, running far above design assumptions; concrete carbonation, acting as a permanent and irreversible gas sink; and a sealed volume too small to buffer either process across 2 years. The carbon dioxide scrubber and the oxygen injection do not just represent operational compromises. They confirm the system was never genuinely closed. The experimental premise was violated by the structure itself, before the first breath was drawn inside it. Biosphere 2 is now operated by the University of Arizona as an open research facility. The interior concrete has since been sealed and coated. The walls, at least, will not absorb the atmosphere again. What the experiment did produce, despite everything, was a precise and reproducible failure record. The atmospheric data from those 16 months remains the most detailed log of a closed ecological system ever collected. Every closed system habitat designed since, every proposal for a lunar base, a Mars transit vehicle, or a long-duration space station has had to contend with the same 2 variables that brought Biosphere 2 down: soil microbial respiration and reactive building materials. The engineering community now models both as standard inputs. Before 1991, neither was treated as a primary design constraint. That shift in thinking came directly from watching 8 people slowly suffocate inside a glass building in the Arizona desert. The lesson is not that closed ecological systems cannot work. It is that the first attempt to build one revealed how many variables the models had missed. The concrete was never inert, the soil was never passive, and a sealed atmosphere has no margin for assumptions. If this kind of forensic breakdown is what you're here for, subscribe. There's a full archive of structural and engineering failures on the channel, and more are coming regularly.